How's it going, guys? Hope you're doing awesome and welcome back to tutorial numero 3. So we're at the point where we're going to create a basic neural network. Now, building and training neural nets has a lot of theory to it. And you can follow this video and build a neural network. But of course, I also want you to truly understand what we're actually doing here. So to keep these videos concise and to the point of learning TensorFlow, I'm going to refer you to different really great resources where you can learn more about the theory. And I really recommend doing that first. The first resource I recommend is 3 Brown Neural Network series, and those videos are really great for building intuition and understanding. And then if you want more depth and explanations, I recommend these video lectures by Andrew Ng from course 1 and 2 of the Deep Learning Specialization. All of these 3 playlists are going to be in the video description. So with that said, let's get started with the code. We're going to import TensorFlow as TF. And before we do that, actually, we're going to import OS, and then we're going to do os.environ, and we're going to do TFF CPP min log level, and we're going to set that equal to 2. And essentially, this will ignore information messages from TensorFlow, but we will still get error messages and so on. Then we're going to, from TensorFlow, import Keras. So let me just explain what Keras is. Since TensorFlow 2.0, Keras is integrated with TensorFlow and is the official higher level API and is essentially the go-to when we're building neural networks and models in TensorFlow. So pretty much when building neural networks, you will use Keras, and then depending on sort of the flexibility that you need when creating your model, you're going to use different APIs of Keras. And more specifically in this video, we're going to take a look at the sequential API of Keras and the functional API. And then we're going to do from TensorFlow.keras import layers. To import the dataset we're going to work with today, we're going to do from TensorFlow.keras.datasets import Mnist. The dataset we're working with today is the Mnist dataset, and I'm going to keep this short because I know many of you are sick and tired of hearing about Mnist. So pretty much, it's images of digits between 0 and 9, and we have 60,000 training images and a test set of 10,000 images. The images are grayscale, so they only have one channel, and the pixels are 28 by 28, so they are relatively small. If you run into any trouble running this on a GPU, then you should try and copy paste these 2 lines right here. But if you don't have any issue, then you shouldn't have to copy them in. Also, I noticed that this here should just be 1F, so TF. All right, so anyways, let's move on now and let's actually start with loading our data set. So we're going to load the training data set. So we're going to load xtrain and then ytrain for the labels, and also xtest and ytest. And we do that by just mnist load data. And then let's print xtrain.shape and also print ytrain.shape. So we have 60,000 images where they are all 28 by 28. Now, one thing here is that we're going to send them to a neural network. So we need to flatten them so that we only have one long column with those feature values. So how we can do that is by doing xtrain equals to xtrain.reshape -1 and then 784. So this -1 here means keep whatever the value is on that dimension. So in this case, 60,000, and then so this is going to be 28 times 28. So we're going to flatten these 2 dimensions here. And also, now when we're loading the data, they're going to be in NumPy arrays, and then they're also going to be float 64. So what we can do is we can do as type and then float 32 just to minimize some of the computation. And then we also want to normalize the value so that they are, rather than being between 0 and 255, we want to make them between 0 and 1 for faster training. So we're going to divide by 255, and then we're going to do the same for the x-test. So x-test.reshape -1, 28 times 28, and then as type float 32, and then divide by 255. So these are going to be NumPy arrays. You could do something like xtrain equals tf convert to tensor, and then you could do xtrain, and similarly for ytrain, etc. But actually, this is going to be done internally by TensorFlow. So if it's in NumPy arrays, we don't have to bother too much. The conversion is just going to happen automatically, so to speak. So the first thing we're going to do now is actually create a model. So we're going to create a basic neural network, and we're going to use the Sequential API of Keras. And how you can view the Sequential API is that it's very convenient, but not very flexible, right? So very convenient, not very flexible. So what I mean by that is, for example, it only allows you to have one input mapped to one output, right? That's a major limitation. But if you have one input to one output, then sequential is exactly what you want to use. So how we create this is we do model equals keras.sequential, and then we're gonna send in a list, and that list is gonna be the layers. So what we want to do first is we want to do layers.dense. So this is for a fully connected layer. And let's say that we want to have 512 nodes in our first layer of the network. And then we're going to set the activation. So we just do activation equals, then we're going to use the relu activation function. And then you sort of write them just as the layers, and then it's going to be automatically sent through those layers. So for example, we want another layer, another fully connected layer, we do layer.dense. And let's say we want 256 nodes in that one, and then activation equals relu. And then for the sort of the output layer, the last layer, we want to have layers dense, and we want to map it to 10 nodes, right? One node for each digit. And on this one, we don't want an activation function because this is our output layer. We're going to use softmax on the output layer, but that is going to be done inside the loss function. So then we're going to do model.compile, and here we're essentially going to tell Keras how to configure the training part of our network. So for example, we're going to specify the loss function that we want to use. So we're going to use Keras losses sparse categorical cross entropy. And then we're going to have an argument that says from logit equals true. And this is because we do not have a softmax activation. So when we do from logit equals true, it's going to send it in through a softmax first, and then it's going to map it to sparse categorical cross entropy. So you're probably familiar with cross entropy loss. When it's sparse categorical, it means that the labels, the ytrain labels, are just an integer for that for the correct label. So for example, if it's a digit of threes, or if it's a digit of 3, then the ytrain of that specific example will just be 3. If you remove the sparse, so you would use categorical cross entropy, then you would need to have one-hot encodings. But that's not what we have in our case. And then we can specify the optimizer. So we're gonna do keras.optimizers.atom, and then as argument we can send in the learning rate. So let's do 0.001. And then we can sort of specify the metrics as well. And in our case, we want to have the metric to be accuracy, so that Keras keep tracks during training what is the running accuracy so far. Then after using model.compile, we can do model.fit. So you could view it that model.compile specifies the network configurations. So what loss functions, what optimizers, and so on. And then in model.fit, we actually specify more of the concrete training of that network. We want to send in xtrain and ytrain, and then we want to specify the batch size that it's going to be trained on. So let's say 32. And then let's say we want to train for 5 epochs. And then we can use verbose equals true so that it just prints after each epoch. Otherwise, you would sort of get a progress bar. But anyways, then after we're training it, we want to evaluate it. So we're going to do model.evaluate, and we're going to send in the x test, y test, batch size equals 32, and then verbose, right? So we don't need to specify the epochs here. We're just going to train it for one epoch. So if we run this now, so just running it for 5 epochs, we get about 99% accuracy on the training set and 98% on the test set, which is reasonably okay, right? So what I want to talk about now is we can do, if we specify the input first of all, so we do Keras.input and we specify the shape of that input. So in our case, 28 by 28. Then we can actually do model dot, so we can do print model dot summary. And yeah, let's exit the code here. So I'm just gonna do sys.exit. And then we can see sort of the network, some information about the network. So for example, we have 512 nodes in our first layer. We have 400,000 parameters there. And then we can see 256, 130, and 130K. And then output, we have 10 nodes with 2.5K parameters. If we would, for example, if we would remove this input, this Keras.input, we wouldn't be able to print model.summary. So we would, or rather, we could print model.summary, but we would have to do it after the model.fit. So after we've actually sent something to the model. So using this Keras.input lets you do model.summary and get more information about the model itself. You could also, so now we created the model where we did sequential and then we specified all of the layers. What you could also do is you could do model equals Keras.sequential, and then you could sort of add one layer at a time. So you could do model.add Keras input, for example, and then shape 784. And then we could model.add layers.dense. So let's do the same network. And then activation equals relu. And then model.add layers dense 256. Activation relu. And then the last layer, layers dense 10. Now, what's amazing about this is that you can sort of do model.add one layer, and then you could do, print model.summary. So doing these model.summary is a common debugging tool. So for example, maybe not for these very simple neural networks, but when you're building more complex models and you want to see sort of layer by layer how much the input is changed for those specific layers, you could do model.summary, and then adding one more layer, you could do model.summary again, and so on. So here are two different ways of using the sequential API. And as I said, it's a very convenient but not very flexible because of the fact that we can only map one input to one output. This doesn't mean that the sequential API is bad in any way. If you can use the sequential API, you should, right? So this is sort of the, if you can't use it, what should you do then? And that's when we go to the functional API. So the functional API is a bit more flexible. I can, for example, handle multiple inputs and multiple outputs. So let me show you how that works. We're going to first specify the inputs. So we're going to do Keras.input and then shape 784. And then we're going to do x equals layers.dense 512. So we're going to build the exact same network. And then we can do activation equals relu. And then after you initialize this layer right here, you're going to call it with the inputs. All right. In this case, sort of the previous one that we defined. And then for the next layer, we're just going to do x equals layers.dense 256, activation equals relu. And then here we're going to send in the previous layer. So this would be x in our case. And then for the outputs, we're going to do outputs equals layers.dense. Then we're going to do 10 nodes. And yeah, just to mix things up, let's do activation equals softmax, and then do x on that. Now, just because we used activation equals softmax here, this from logits will not be true. So we're going to have to change that to false, which is also the default argument. So we could also just as well remove this entirely. So let's rerun this now and see that it works. All right, so I'm sorry about that. I forgot one line here, which is very essential. So one thing we saw here is that the accuracy didn't improve, which, if you think about it, here we didn't use softmax on this model, and this is the one that we latest defined. So you could see sort of here how important using softmax is. But anyways, what we need to do here is we need to do model equals Keras.model. Then we need to specify inputs equals inputs, and then outputs equals outputs. All right. So that's all we have to do, and it's gonna take these inputs that we defined here and these outputs and build the model. And now if we run this, this should hopefully work. So as we see now, we get something very similar to the first time we ran the model, about 98% and about 98% on the test set. So as usual, you could also do print model.summary right here and sort of get information about the model. One thing you could also do is you could name the specific layers. So we could do something like name equals first layer, name equals second layer. And then if we run model.summary, we will see right here that the first layer, first dense layer, since that's the one we named, it's going to be named first layer and then second layer. Now, I also want to show some details of how to extract specific layer outputs that might be useful when debugging and so on. So this is going to work no matter if you're using the sequential or the functional. Let's just do it for the sequential. So I'm going to do sys.exit right here, just so that we're focusing on this model right here. So what we're going to do is we're going to overwrite this model, and we're going to do model equals Keras.model. Then we're going to do input and inputs equals model.inputs, and then outputs. We're going to specify model.layers, and then if we do -1, that's going to be the output, right? That's going to be the last one. So if we do -2, for example, we're going to get the layer before that. And then we need to specify dot output. So then we could do something like feature equal model.predict. So model.predict is for a specific a specific one that we send in. So let's do xtrain. In this case, we're sending in multiple examples, actually all 60,000. But anyways, we can do print feature.shape. And then we would obtain all 60,000 and then 256 for that specific layer. So that's one way you could do it. What you could also do is you could specify, you could give it a name like my layer. And then you could do, here you could do model.get layer. And then you could specify my layer and then dot output. So if we would run that, we would get the exact same. We are just getting the layer based on the name of that specific layer. Also, you could get all of them. So you could do layer.output for layer in model.layers. And in this way, we would get all the features. So for example, we could do for feature in features and then print feature.shape. So if we run that, we would now obtain the output from all of the layers. So we would get the first layer, the second layer, and then the third layer. So this might be useful sometimes when you're debugging and so on. But yeah, so let's remove those actually so that the code is actually working as we wrote it from the beginning. Here are a couple of suggestions to play with the code and to get some more experience. So the first is that you can try and see what accuracy you can get by increasing the model size, training for longer, etc. And you should be able to get over 98.1% at least on the test set. And my second suggestion is try using different optimizers than Atom. For example, try gradient descent with momentum, AdaGrad, and RMS prop. Which one gives you the best results? And then thirdly, is there any difference if you remove the normalization of the data? So those were some of the basics of creating neural network with Keras using the sequential and the functional API. In future videos, I'm going to show more complex examples of the functional API. But before we do that, we're going to learn how to do convolutional neural networks in the next video. So with that said, thank you so much for watching, and I hope to see you in the next video.